Okay, so now having known our chapter 9, the similar figures, chapter 10.1, similar areas, chapter 10.2, similar volume. So in 10.3, we are going to see a mixture of these area and volume problems. Okay, so we are going to go back and forth between the area and the volume, so we really need to see how it works. Okay, and it's actually quite easy. Okay, as long as we are firm that length to area, the length need to square to make the two dimension. Then length to volume, we need to cube the length to match the dimension of the volume. Okay, so let's take a look over here. So ratio of length, it will be 4 over 5, right? 4 is to 5. Then the ratio of area is going to be 4 over 5 square. Okay, ratio of volume, 4 over 5 cube. So this is something that we just need to take note. Okay, so this is what we've been doing so far. Okay, same thing over here. So let's say if now we are starting with area. Okay, if now we are starting with area, so the ratio of area is 15 over 240. So this is going to be two dimensions. Okay, so how do we express the ratio of the length? It is still 15 over 240, correct? But the lengths need to square to get the area. But now with the area, how do we go back? We need to square root. Okay, we need to square root. So technically square root is just power half. Okay, then what about the ratio of the volume? It is a ratio of the length cube. So when we get from here, we cube over to this side, we are going to have 15 over 240, right? 15 over 240, but it will be a 3 over 2. We are going to cube this. So you see how this works, right? So once we get the ratio of area, it will be easy to go back and forth already. Okay, now let's push one more to the next one over here. For part 3, we have the ratio of the volume. Okay, ratio of the volume is 2 to 16. So the reference point that we can get from 2 over 16 is to the length, right? So the length will also follow 2 over 16, but because the length you cube to get the volume, from the volume you cube root to go back to the length. So over here by right I need to put a cube root, but cube root I can rewrite this as index form power 1/3. Remember? So over here, right, we will need to so how do we get from here to the area? From the length we square to get the area. Okay, so over here I have a 2 over 16 and I have a 2 over 3. Okay, so let's take a look at the motion. So from length to area we square, right? Then from length to volume we cube. Okay, now over here if you look at this example, given the area, in order to go back, the reverse of a square is to take a square root, and to go forward we will need to cube. Okay, then one last thing over here is given the volume, the forward is cube, the backward is going to be cube root, and to move forward over here we square. So this is what we do for these three questions. Okay, let's take a look at 4 and 5 just to really consolidate our idea. Okay, for 4 and 5, okay, my apologies. So for question 2, right, actually these are areas, correct? So for question 2, we don't have volume for these two shapes. So technically speaking, we can just ignore this. Okay, we just ignore this. But let's say if you are talking about a cube, okay, a similar cube. So this is how we play with the whole process. Okay, we'll cube to find the area of a volume if we have a volume of pyramid with the same base, that kind of thing. Okay, now similarly for question 4, okay, same thing. We have 0.4 over 0.2. Okay, so this is length, correct? 0.4 over 0.2. So the area will be 0.4 over 0.2, but we square it. For the, okay, so really for this one, because this is area, so this one don't have no answer. Okay, for volume, no answer. Now, then for this one over here, we have a 54 over, no, 16 over 54 as the ratio of length, ratio of volume. Okay, so then in order to go back to the ratio of length over here, we normally do cube root, correct? So over here we have a 16 over 54, but power 1/3. Then what about the ratio of their surface area? We need to square. So over here will be 64 over 50, 16 over 54, and then 2 over 3. Okay, power 2 over 3. Okay, so this is how we go along with this. Okay, so now last but not least, let me write down something. So a1 over a2, right, would be length 1 over length 2. Okay, and then this one need to square. v1 over v2, it is length 1 over length 2. We need to cube. Okay, we need to cube. Then in order to, like to match them up, in order to match them up, right, we have our a1 over a2, right? We square root to get this one. For v1 and v2, right, we cube root to get this length ratio. And because the length ratio are the same, so technically speaking, a1 over a2, when we square root, it will be equals to v1 over v2 when we cube root. Okay, so means that we can go back to the length. Okay, we can match them, we can communicate between the length. Okay, so this is how we are going to approach these kind of questions. Okay, so without further ado, let's take a look at a few examples over here. Okay, so the areas of the, question 10b, exercise 10b, question 5, the area of the bases of two similar cones. Okay, so we have two similar cones, one cone, another cone, right? The base area, the base area, this is 9 parts, this is 16 parts. Okay, so find the ratio of the heights of the cone. So it means that I'm looking for h1 and h2. h1 over h2. So h1 over h2 is equals to a1 over a2, correct? But we need to square root. Agree? So the ratio h1 over h2 is equals to 9 over 16 square root. So this is going to be 3 over 4. Okay, so this is 3 over 4. So the answer, okay, wait, let me push this here. Put it here so it's nicer. So over here the ratio is 3 parts is to 4 parts. h1 to h2 is equals to 3 parts to 4 parts, like that. So given that the volume of the larger cone is 448, find the volume of the smaller cone. Sure, for the volume of the smaller cone, okay, we match it to the volume of the bigger cone is equals to the height of the smaller cone to the height of the bigger cone, right? So then this one we need to cube. So so this is the relationship that we have, right? So how do we find this? How do we gather this? So the volume of the smaller cone over volume of the larger cone is 448 equals to small height to big height is 3 to 4, like what we find earlier, but we cube. So the smaller volume is going to be equals to 448 times 3/4 cube. Remember the bracket. So this is 189 cm cube, right? So 189 cm cube, like this. Okay, quite straightforward. Okay, again, let us for this one, okay, for question 6 we are skipping. You can try yourself. For question 9, okay, let's settle question 9. Okay, over here it says that, right, the volume of one sphere is 4 times of that the other sphere. Okay, so what does this mean is that the volume of the big sphere over the volume of the small sphere, the ratio is 4 times, right? If you were to multiply this across, V big is equal to 4 times small volume. Agree? Right? So given that the radius of the smaller sphere is 3 cm, find the radius of the larger sphere. Sure. So the radius of the larger sphere over the radius of the smaller sphere, when you cube, is going to be equals to the ratio 4. Okay, V big over V small. So if you're not convinced, right, you can write down the formula. Okay, big radius over small radius. When you cube, you're going to match it to the big volume over the small volume. Okay, like that. Okay, so with this one, so the big volume over 3 is going to be cube root of 4. So the big volume is 3 times the cube root of 4. So this is going to be 4.76 cm to 3 SF, because sadly we need to, yeah, there's no like nice numbers to this. Okay, so this is how we settle this one. Okay, the last question that I'm going to do is this question over here. So the figure shows a container in the shape of an inverted right pyramid of height 27 cm. It contains a volume of vegetable oil which is equals to 1/6 of its full capacity. So over here, right? This sentence, right? It tells us that the volume of the vegetable oil is equals to 1/6 of the capacity. Right? 1/6 of the capacity, or the volume of the full thing. Okay, volume of the full thing. Right? So if you want to write as a ratio, so V oil over V full is going to be 1/6 as a ratio, like that. Okay, so find the depth of the vegetable oil. Sure. So the depth of the oil, right, when we divide by the depth of the full thing, is going to be equals to volume of the oil over volume of the full thing, correct? But the depth is a one-dimensional length, so we need to cube this. Volume is three-dimensional, so it's fine on its own. So the depth of the oil over the full thing is 27 cube is equals to V oil over, so this will be 1/6. So the depth of the oil is 27 times 1/6 cube root. Okay. So this is going to give me 14.8587, so roughly 14.9 cm. So 3 SF, like that. Okay, 14.9 cm. So now the ratio of the area of the top surface of the vegetable oil to the, okay, we want to find the ratio of the area on top to the area of the top surface. So over here, this area over here versus this big area over here. Do you see this? Right? Okay, area of the full thing to the area of the oil, giving your answer in the form of 1 to n. So the area of this, okay, area of the full thing over the area of the, area of the oil as compared to the area of the full thing, right? It's going to be equals to 1/6, right? But cube root. Agree? Okay, because this is going to be equals to the depth of the oil over depth of the full thing. Okay, but this one will need to square, right? And previously we found out that this one, right? This one, this ratio, okay, depth of the oil to the full thing is 1/6, right? But to power of 1/3, this is cube root. Okay, and we have a square on the outside. Okay, so by law of indices, by law of indices, we're going to see 1/6 to the power of 2/3, right? So this is going to be equals to 1/6 to the power of 2/3. So this would be 0.3028, something like that. Okay, sorry, bad move. Okay, so let me do this. Because we're looking for ratio, and this one a bit special. We are looking ratio, right, in the form of 1 to n. So means my fraction must be 1 over n, something like this. Okay, so means I will need to do something like this. So this will be 1 to the power of anything is 1. Then 6 to the power of 2 thirds, I'm going to write 6 to the power of 2 thirds. Okay, so then my ratio, area of oil, or the top of the oil, to the area on top of the full thing is equals to 1 part is to 6 to the power of 2 thirds, like this. So this is going to be 1 to 6 to the power of 2 thirds is 3.30193. So roughly 1 to 3.30 to 3 SF. Okay, so this is how I will form my answer. Okay, so giving my answer in the form of 1 to n, so means I need the 1 on top and the random number below. Okay, so this is how I do my final answer. Now, one more time, so what did I do earlier? The depth of the vegetable oil, I take the volume, right, the volume, ratio volume, and I find the length, right? In part 2, in order to be accurate, I didn't use the 14.9, but instead I used the 1 over 6 to the power of 1/3, or 1 over 6 cube root. Okay, and then I square. The reason is because it will give me a more accurate answer as compared to using the previous part. Okay, so the challenge of this part would be to recognize which what does the question ask, right? Are you looking for area? Are you looking for volume? Is it a big one? Is it a small one? Okay, so that's the challenge within these questions. Okay, so now is good time to wrap up. Okay, this chapter we extended our concept from chapter 9. We extended the similar length, similar figures, so we similarity test, and then we apply a little bit of similar figures. So in chapter 10 we do similar area, similar volume, and for area we got one more special case where if the triangles are not similar but they share a common height, then the ratio of the triangle would follow one dimension because the height will cancel itself. Okay, so this is the whole part for chapter 10. Very easy chapter. Very, very easy chapter. So make sure you know how to do questions from this chapter. Be patient, read the question carefully, and you just do it. Okay, make sure the dimensions matches. So that's all for the day. Have fun and finish these worksheets, and you double check the answer that I will send to you soon. Okay, bye bye.